Hope you're doing well. So in the last video, we learned the simple 5 lines code that the LlamaIndex offers, which is a very basic code just to get started with the RAG pipeline on top of an LLM. Okay, so in this series, in this part, we will learn about how to customize some things further. Okay, so now if you don't want to dive deeper, just using this high level API without without actually moving to the low level API, you can actually perform some further customizations according to your context, or you can say according to your use case. So let's dive a bit deeper into it. Okay, so the context that I'm currently using is on a fictional character, John Doe, who was basically a machine learning engineer, and he likes to, learn about mathematics, and he loves to, and he's maintaining an open source package, PyClean. So yeah, now let me show you some things that you will always be needing while working with a RAG pipeline. Okay, so first of all, sometimes you might need to check out that how much tokens your context is of. So like you really need to take in account for this, because sometimes your context can increase the maximum context length of an LLM. So oh wait, this is not the one. Map on dot tokenizer. Yeah, this one. Okay, so let's see. Controlled. Okay, so currently our context is around 241 tokens. Now, this is not a very big context. This is just for some, testing, initial testing and all that. So you won't be facing any problems with the context with this length, but you can also extrapolate this context further onto bigger context, like as long as you have maybe like maybe 10, 20, 30 pages for on a PDF or something like that. For maybe you have 10,000, 50,000, or maybe even 100,000 tokens. So this should work pretty well on those use cases. But if your context crosses maybe 1 million tokens or something like that, that might be, then will need to use some different optimization solutions. But for maybe 100,000 tokens or 200,000 tokens, this will work pretty well. Okay, so let's see. Now, let's suppose that currently we have 241 tokens. Now, I'll provide you something which you won't find in the documentation, but this will help you in identifying what context is being used to generate responses. So, I won't go into, because currently this part covers some surface level APIs. So I won't go into detail about what are these nodes and these query engines and all that. So, but obviously I'll go into detail later on. Uh, but I'll give you an idea of how this is working. Okay, so this is basically this node with score. This you can understand it like this, that is, it's basically the context, or the context that the context you're fetching based on your query from your actual context.txt file. Okay, so now let me give you an idea of what's happening here. So this was my complete context. Okay, so let's suppose that I answer it. Let's suppose that I ask a question that where does John enjoys hiking, or where does John go for hiking? Let's see what it responds. Where does John go for hiking? Okay, as you see, this went pretty well. Now, let's suppose that I'll tell you in detail of what this actually means, but let me similarity top. Okay, let's keep this one, and let's let's keep the chunk size less than 2, because the default chunk size that LlamaIndex is using is actually, I think, somewhere around 512, or maybe, I don't know, 1024, somewhere around that. But because our context is less than 512 tokens, so obviously all of our context is being sent as, as an input to GPT or to the LLM. So obviously we won't be seeing much results, but we can control that by settings, and by setting settings dot chunk size. Let's set it to 1 to 8. Okay, so you'll see that this should create around print calculator. So we had a chunk size of the context was around 241 tokens, and if we set our current chunk size to 128, you'll see that it's 1.88. So this just means that our currently our two on two nodes will be created, not one. As you can see, for currently, when I without any settings, we had only single node, but with two chunk size, we'll have two different nodes. So let's proceed with that. I've already said, okay, so now I am hoping that this LLM wouldn't know that where will he go for hiking. Why? Because this should be in the first chunk, and not in. And as you can see, there is no information, because I only retrieved I only retrieved a single node. Okay, I didn't used the complete context for, let's 0.text, I think. Yeah. Okay, so let's see. Our current context was started from John Doe, and it went till data cleaning pipelines. Let's see where till where our context was saved. From John Doe till data cleaning pipelines. Where can we find data, control F? Yeah, over till here. So as you can see, this basically, what happened is, behind the scenes, what happened is that our total context was around 240 tokens, but we just fixed it that it should be 128 and not 256 and or 512. So when it used only 128, and we also limited that the number of results should be fixed to only one. Now you'll see that if I use it as two, it will, and you can also see that there was only a single node that was generated and not two nodes, because we specified that we only need the first result. We didn't need the second result. So let's suppose if I specify that two, and now I get the response. So you'll see that yeah, John goes hiking. And now when I'll print the response nodes, you'll see that now I have two nodes, because basically what happened is I basically fetched the two most matchable nodes. And that's how it basically worked. Now, as you can see, for the node 0, the response was pretty much the same, the data pipeline till data cleaning pipelines. But if I select the second node, now what happened here is, behind the scenes, it all of it was combined and then sent to GPT using you can say using a query engine. And the query engine basically using the low level API. Obviously they are leveraging the low level API, so it basically merged the context with our prompt, and the prompt this query, and this query was then sent to LLM to actually fetch the results. Default is, as you can see, I never specified any LLM or anything. So the default is basically OpenAI. So basically this is happening through OpenAI. So this is a very good use case if you have to, fetch more results, or fetch, now for longer context, you can specify this result as 3, 4, 5. But as you can see, we only had two results, because we had a very specific chunk size. But if you going further, you can specify it to any number of, like, let's suppose if I had a context that was around maybe 2000 tokens, right? So if I had 2000 tokens of context, then I would only need a single, and I specified the chunk size as maybe 128 tokens. So basically, we would have around 16 nodes, 16 different nodes. And amongst those 16 different nodes, if I were to, send this query, and it would be matched up with these 16 nodes, and then I would be able to use this similarity top k and, specify maybe 5 or 6 or maybe 7. So anything like that. And then I'll be able to get answers for the top from the top matched queries from the top matched context. So this is a very high level of how the context work. So this is one way where you can, um, how you can alter the chunk size.